Alright, the last method here we're going to talk about with solving systems is a form of elimination, but we're going to have to multiply either one or both of the equations first before we can add or subtract them. Alright, so if we want to use elimination to solve this system of equations, we can't add or subtract it as is to get either the x or the y to cancel, so we're going to have to do something to it before we can add or subtract it. And we're going to have to multiply either one of the equations or both the equations by something. As I look at the x's, I see that there's a negative 5x and a positive 1x. Well, if there was a positive 5x, if there was a 5 here, then we could just add the equations and it would cancel. So I'm going to manipulate the second equation by multiplying everything by 5. So that when I do that, 5 times x gives me 5x. Negative y times 5 is negative 5y. And 5 times 4 is 20. I'm going to keep the top equation the same. I'm just going to recopy it over here. And then after we've got that, now if I can just add these two equations together, negative 5x and positive 5x is 0. Positive 3 and negative 5 is negative 2y. And if we add 6 and 20, we get 26. Divide by negative 2. So y equals negative 13. I'm going to take this now and plug it into the other equation there and solve for x. So if I got x minus negative 13 equals to 4, minus a negative is like adding, so I'll rewrite the equation as so. We want to solve this, subtract 13 on both sides. So x equals negative 9. We write our solution. Just remember that we've got to do the x value first, y value second. So we're going to have negative 9, negative 13. Let me clean that answer up a little bit. The eraser is not cooperating right now, so I'm just going to leave it as it. Negative 9, negative 13. Okay, so we look at these two equations as they currently are. If we were to add or subtract them, neither the x or the y would eliminate or become 0, so we're going to have to either multiply one of the equations or both of the equations by a number so that can happen. As I look at right here, I got 4y and 2y. Well, it would be nice if this, instead of having a positive 2y, it'd be nice if that was negative 4. And I can easily make it negative 4 because if I take 2, I can multiply by the entire equation by negative 2. If I do that, negative 2 times 5x is negative 10x. 2y times negative 2 is negative 4y. And negative 2 times negative 4 is a positive 8. We're going to leave the first equation as is. Okay. Now if we got it set up and changed so that if we add these two equations, we're going to have the y's eliminate. 3x minus 10x is negative 7x. 4y minus 4y is 0. And then 6 plus 8 is 14. So we have negative 7x equals 14. Divide by negative 7, divide by negative 7, and we have x being equal to negative 2. Okay, I'm just going to recopy the first equation. Going to take the x value we found and plug it in there so that we can find y. So we have 3 times negative 2 plus 4y equal to 6. So we got negative 6 plus 4y equals 6. Add 6 to both sides. So then we have 4y equals 12. Divide by 4, so y is going to equal 3. Remember, when we write our solution, we're going to write the x first, y second, so we have the point negative 2, 3. Okay, in the previous examples, we've only had to multiply one of the equations so that we could add or subtract to eliminate one of the variables. This one we're going to have to multiply both of the equations by something. As I look at the equation, I notice that there's different signs for the y's. There's a 4y and a positive 4y and a negative 3y. I want to find the common factor between those two, and that would be 12. So I'm going to take the first equation and multiply everything by 3. Then I'm going to take the second equation and multiply everything by 4. So when we do that, the first equation, 3 times 3x is 9x, 3 times 4y is 12y, and then 3 times negative 25 is negative 75. If we multiply everything in the second equation by 4, 2x times 4 is 8x, negative 3 times 4 is negative 12y, and 4 times 6 is 24. So now we can look at this and add them together. If we do that, 9x and 8x gives us 17x. Negative 12y and positive 12y is 0. And this gets us 51 when you take negative 75 and add 24 to it. If we look at this now, we get 17x equals 51. Divide both sides by 17. So x is going to equal, oh, it's a negative 51 over there. Sorry about that. That's going to equal negative 3. Now I'm going to rewrite, I'm just going to rewrite the second equation here. We got 2x minus 3y equal to 6. I'm going to take this, plug it in there, so we have 2 times negative 3 minus 3y equal to 6. Negative 6 minus 3y equal to 6. Add 6 to both sides. Negative 3y equals 12, so that way y is going to have to equal negative 4. As we write our solution, we're going to put the x first, the y second, so we're going to have the solution of negative 3, negative 4.